Why, hello. Nah, hey kiddos. What's up? What's happening? Today we're going to go into triangle proofs. Yay! All right, so first thing that I want to remind you guys of is what is an angle bisector? Remember, it is a segment that basically cuts an angle into two congruent parts. Okay, so whenever we're solving proofs, it is very important to recall all of our theorems, definitions, and postulates that we have learned. Okay, things like side, 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 or side, angle, angle, side, and even things like the reflexive property. Okay, all those things are going to have to go into effect. So, given that AD, what does this symbol mean? That means it is parallel. So given that AD is parallel to EC and that BD is congruent to BC, prove that these two triangles, ABD and EBC, are in fact congruent. Now, I'm going to make this mark here and this mark here. Remember, this is not a congruency mark. These are those little triangles to prove that those are parallel, since that's what they told me here. Okay, let's see. So, first statement, BD is congruent to BC. Hello, it was given. Piece of cake. Next statement, AD is parallel to EC. That is also given. Okay, so check and check. Now, here it says that angle D is congruent to angle C. So, let me make that mark here and here. Now, the question is, why would that be true? Now, imagine this. We have these two parallel lines, right? And then we have DC. This is where D is, and this is where C is. And they basically serve as a transversal. So we should hopefully recall something special about alternate interior angles. This angle here and this angle here are on different sides of the transversal, but inside the parallel lines, and we know that alternative interior angles are in fact congruent. So angle D can be proven congruent to angle C because of alternate interior angles are congruent. Next, we are given, or not given, but we have as a statement angle ABD, angle ABD. So notice typically when we name an angle with three letters, ABD, we're referring to the angle basically that's in the center or in the middle of that. So I'm going to make a marking there, is congruent to angle EBC, which would be this angle here. And oh, well, of course, these two angles are congruent because of vertical angles. So let's see what we have here. We have an angle, a side, and an angle. We have an angle, a side, and an angle, and in that very same order. So therefore, we have angle, side, angle as our reason for these two triangles to be congruent. All right, given that R is the midpoint, okay, so that means R is the point that's in the middle of that line of SU, and SV is congruent to UV, prove that triangle RSV is congruent to triangle RUV. All right, before I actually get started in all of this business, I'm going to deal with the given information first and make sure everything is marked appropriately. So it says R is the midpoint of SU. So if R is the middle, then that would tell me that this has to be congruent to this. SR has to be congruent to RU if R is the middle of line segment SU. Okay. Then they also tell me that SV here is congruent to UV here. All right. Now that I have marked or written down all of our given information, now let's go with our proof. Statement. First statement. R is the midpoint of SU. Well, the reason is pretty simple. It is given. So, next part is blank. And the reason is the midpoint theorem. Well, what did we prove is congruent because of the midpoint theorem? Oh, we proved that SR is congruent to UR. Okay, because of the midpoint theorem. 12, next statement. Well, it gave me a big hint here to tell me it's given, which is the SV is congruent to UV. Okay, and that was given. And then 13 here. The reason is reflexive property. What do you know? Can make those markings there because we know that both triangles share that side. So therefore, RV is going to be congruent to RV because of the reflexive property. So these two triangles are in fact congruent. Notice that had nothing to do with this right angle here is misleading information. We don't even need to use that at all because this triangle is congruent because of the three same letters, which are S, S, S. Side, side, side. All right. Given that triangle DGH, where is DGH? Okay, so the middle triangle. Notice we've got three triangles here. Well, technically four. Five. Well, more than that, but okay. Anyways, 1, 2, and 3. That's what we're going to focus on. 1, 2, and 3. DGH, okay, is an isosceles. Then they also tell us that DF is congruent to DI, and angle FDG, so this angle here, is congruent to IDH, this angle here. Prove that triangle FGD is congruent to IHG. So the two triangles that we're trying to prove congruent, I'm going to put a 1 and a 2 in, are those two. Okay, so these two here. All right, those are the two that we're focusing on. So let's mark what we need to. What does it mean by isosceles? Remember, if it's an isosceles, that means two sides are congruent. So they were talking about this middle triangle here. And if two of the sides are congruent, I believe they're referring to DG and DH. So I'm going to make that mark there first. All right, so check. We just did that given information. Second piece of information is that DF is congruent to DI. So I'm going to make check there because we just marked that. And they give us one more piece of information, angle FDG. This angle here is congruent to IDH, which is this angle here. So I'll make those marks. All right, so triangle. Now we're going to work on our statements and figure out all our reasons for this one. Triangle DGH is isosceles. Very simple reason. It's given. DG is congruent to DH. That would be because of the definition of isosceles, which we kind of already talked about. Next one, DF is congruent to DI. Then that was given information. Next one, triangle. Angle FDG is, oh, what do you know? Another easy one there is given information. So based on that information, why are these two triangles then congruent? Let's see, we have a side, an angle, and a side. I can clearly see that this angle here is included, meaning it's in between my two sides. So therefore, this is a side angle side. Oh, and of course you knew it was coming on your own. I have to start doing this shorthand. I saw somebody do it. Oh, yo. Instead of YOLO. Oh, yo. Get it? Got it? Good. So you guys are going to do this one on your own. You have your given information. You're trying to prove these two triangles are congruent. I was kind enough in providing you with an answer bank. Now, hopefully, you see that there are way more answers than there are fill in the blanks. So you do not have to use all of them. All right. I would actually challenge you to imagine this is not here. You know, just act like it's not even there and try it on your own first. Okay? And then if you absolutely must, then you can refer back to it. All right? Adios.